Okay, guys, today we're talking about inverse functions and inverse of relations. So basically, we have some kind of relationship, and they call it R, and we have the inverse, which of course just means the opposite of that, and we're going to call that R inverse. So R with the little -1 in the top corner. Okay. So now, how do you actually find this inverse relationship? Well, all you have to do is switch the inputs and outputs, or the domain and range of your original function. Okay, domain and range of R. Okay, so we'll get back to what one-to-one means, but if we just look at the next one, we can see kind of like, hey, 1 comma -2, that one's simply just going to become -2 comma 1. 2 comma 4 is going to be 4 comma 2. 3 -1 becomes -1 comma 3, and -2 comma 4. So you can see each one just switch spots. All right, and once we've got that, boom, I put the little set brackets around it. There you go. Now, you may remember, how can we tell if R is a function? Well, remember, you should not have any duplicate x values. Okay, so if you look at all your x values, boom, no duplicates. Looks like R is a function. Yes, boom. Okay, now is R inverse, the inverse relationship, is that a function? Well, let's take a look. Do we see any repeats in the x values? Yep, we got a problem right there. So no, this is not an inverse. Okay, and or sorry, not a function. And what that means is this is not going to be one to one. Okay, so one to one, R and the inverse relationship are both functions. Okay, so there's a quick test to also checking that, but just look for duplicates in the x's either way, basically. So if we see the original function has a duplicate, that would mean that R isn't a function. If you see it after you flip, then your inverse is not a function. All right. So if y'all want, you can take a second and do number two. Once again, just flip the points and see if you're drawing the right conclusions. I'm going to pause and then I'll fill in the solution. Okay, guys, so I'm hoping that now you've gotten that your inverse is 5 comma 1, 6, 1, -4, 3, 9, 4, and you can see, hey, is R a function? Absolutely not, because we've got that one duplicate right there. So R is not a function. The inverse, however, is a function. Okay, the inverse has all unique x's, so we're good on that, but still not one for one because it is not going to have those matching pieces. Okay, now the third one, guys, has the bubble diagram. You should remember how to read this. Remember, x and y points are connected together with an arrow. So for example, the very first point seems to be 0, 6, which means in my inverse I've got 6, 0. Okay, and we got 1, 2 becoming 2, 1, and we got 11, 6 becoming 6, 11. So you can see, hey, is R a function? Yes. Is R inverse a function? No. And is it one to one? Once again, no. Okay. All right. So that one's kind of a funny one. Just remember, y's can repeat, not x's, though. Okay. All right. Moving along real quick. All right. Once again, guys, pause this. If you're missing some of this, make sure you pause and get this down. Okay. All right. Real quick, talking about the line tests. You guys should remember the vertical line test will tell if the relation is a function. So that's talking about R. The horizontal line test will tell you if the inverse of a relationship, which is R minus 1, is a function, right? So if they are both functions, then it's considered to be one to one, okay? So for example, hey, we do the vertical line test, we do the horizontal line test, and you see that, hey, number 4 is going to pass both of those. And you can say, hey, this is a one-to-one relationship, okay? And if you look at the second one, you're going to see, hey, look, this will pass the vertical line test, but it is not going to pass the horizontal line test. So let me do that a little nicer. If we do that, boom, you can see it hits in 2 points. So I'm going to put this fails the horizontal line test. The inverse is not a function. Okay, so our inverse is not a function. And again, if either of these are not functions, this cannot be one-to-one. Okay, so HLT, once again, guys, is the horizontal line test. That's going to tell you if the inverse is a function, whereas the vertical line test tells you the normal is a function or not. Okay. All right. Once again, guys, make sure you take a second, go back in this video. If you missed something, make sure that you get all your notes for this. All right, let's check out the second page now and talk a little bit more about using inverses with functions. So an inverse function, right, they've said, hey, if you've got a function f of x, you've got f with a little -1 of x. We call that f inverse of x, the inverse function. Now, they've kind of mentioned what the steps to finding the inverse function are, and basically, it's pretty straightforward once you do it a couple of times. So basically, rewrite it as a y equals first. Y equals 5x, and then we're going to switch x and y, right? So we're going to make this x equals 5y. Now, we get y by itself again. So again, we'll do all the little math. Even though some of it may seem silly. Divide by 5, cancel these out, and I've got x divided by 5 is equal to y. And then we'll rewrite it again as a function notation, right, with the f of x, but this time I'm going to write it as x over 5 equals f inverse of x. Okay, so once again, we switch back to the f of x notation. But notice I'm putting this -1 to show that this is, in fact, the inverse relationship, not the original. Okay, so we'll note that little -1 means inverse. Boom. Okay, all right, so let's do another one together. We'll do the next one down in the row, number 8. It's not too bad, it's still kind of the same idea. Oops, not highlighter. Y equals x minus 8 over 3. Switch the x and y's out. So I've got x equals y minus 8 over 3. Now, what am I going to do as I try to get this y by itself again? Let's do times 3 to both sides. So I've got this now. 3x equals y minus 8. Let's move our 8 back over. So we got plus 8 plus 8. 3x plus 8 equals to y. And boom, that's going to be my inverse. Now, make sure that we write it in the correct notation. So we're going to write 3x plus 8 equals f inverse of x. Don't forget that little -1. That's important. That tells us that we found the inverse of this. Okay. Okay, guys. I'm going to give you guys a second. Why don't you guys try number 10? Follow the same steps, right? Start by rewriting this as y equals x squared minus 9 and go from there. I'll pause for a minute so that you can try. Okay, I'm hoping that you've already paused and solved this, so I'll go kind of quick through this. First thing, we're going to switch the x's and y's. So I got x equals y squared minus 9. Now we can add 9 to both sides. Okay, so I've got x plus 9 equals y squared. And now remember, guys, how do I get it to be just plain y by itself? We're going to take a square root. And just to be super formal, we will go ahead and put that plus minus in the front. Like I told you guys, you should always put that in the front, equals to y. Okay? And now we can say, hey, square root x plus 9, either way, is the inverse function of x. Now, I'll tell you something, guys. If you ever see a plus minus in your function, you'll know, like, hey, wait a minute, this is actually not a function. So this one, the inverse, is not a function. Okay, awesome. So, guys, I'm hoping that you understand how to find these inverses. Remember, just switch the x and y, right? It reflects switching your domain and range, just like we did with the coordinates. You're switching out the actual variables now. And get that y back by itself. Make it nice and pretty. Boom, you've found your inverse. Okay. Now, I'm hoping that hearing the word inverse, you've understood that inverses must be opposites of one another, right? If something is increasing by 8 or plus 8, the inverse is obviously going to be minus 8, the opposite of that. So two functions are inverses only if they're opposites and can cancel each other out, right? So how could we show that? Well, if you take f of g of x, and you see that both of those f and g's are canceling out, you would be left with just x. And we could kind of do the reverse of this, right? So we could do g of f of x, and we should also get this to cancel out, right? So either way that you plug it in, we should be seeing, hey, these are going to cancel out, right? So for example, with number 12, okay, let's see if we are in fact able to get these to cancel out. So we'll do f of g of x. So first of all, wherever there was an x, I'm going to leave a blank for now in f. So I've got blank squared plus 8. Okay, so every single x I had, I'm going to leave that little blank there. Okay, and now once I've got my blank, we'll fill this in using the other function because it's not x anymore. Now it's g of x. So let's put in square root x minus 8. And let's see if things actually cancel out nicely the way we want them to. Root 2, like that root and that squared are going to cancel each other out. So I've got x minus 8 with that plus 8 in the front. And you should pretty much have it from here. You're going, hey, these are going to cancel out. And I'm just left with x. Okay. So it looks good so far, but we're going to check both ways. We're going to make sure that we do it the other way as well, which would be g of f of x. And we're just plugging it in and making sure that they cancel out the other way. So now I've got square root blank minus 8, and now I'm plugging in x squared plus 8. And this time it cancels out kind of in reverse order, but you should see that, hey, these are going to do the same thing. The 8's are going to cancel out, and I've got square root of x squared, and we get that that's just equal to a plain old x because the two square roots and the square cancel each other out, right? So these two are in fact inverses, right? So f and g are both inverses. Guys, give number 13 a try yourself, okay? Go ahead and pause, try to do f of g and g of f, plug them into each other, and see if they cancel each other out. If they do not cancel out, you will know these are not inverses of one another. Okay, so take a second, you guys try it, and then I'll show you what I get. Okay, so here's what I've gotten. So I know that f of g of x. So once again, I'm going to write out f negative 4 blank plus 5. Okay, and it's always important to be careful with your algebra here, right? So I've got x over 4 minus 5. And it's really easy to get excited and be like, I'm gonna cross these 4's out. However, guys, this negative 4 is gonna actually distribute into here. So negative 4 and over 4, those are gonna cancel out. And I'm gonna be getting negative x, and negative 4 times negative 5 is plus 20. And then don't forget about that plus 5. And you can already see this is not canceling out nicely. I'm ending up with negative x plus 25. That's definitely not supposed to be right, right? And so I kind of know this is no good. So I can kind of throw that one out. But let's go ahead and see kind of if the other way works out. It's odd if it would, but let's just double check and make sure that we are certain about this. So now we'll do it the other way. I've got blank divided by 4, and that's going to be minus 5. And in my blank, what am I going to plug in? The f, so negative 4x plus 5. And once again, you're going to see like, hey, you might be tempted to try and get these 5's to cancel out. They do not, because they are locked up over this 4. So if you start simplifying this part, you're going to get negative x plus 5 over 4 minus 5. And you're like, wait a minute, these two do not actually match up, do they? And I keep getting some weird nonsense like this. And you could simplify this further and get it to be like, hey, that's going to end up being, this is like, what, 20 over 4? So you can get it to be some fraction, negative 15 over 4 minus 15 over 4. And the basic idea is that it's not equal to x, right? So these are both not equal to x. So f of x and g of x are not inverses, okay? And on the first one, they are inverses. Write that a little better. Okay, so if they are inverses, they should cancel out and you should get x for both of the answers. If you do not get x for some reason, you know that they are not inverses. Okay, so guys, that is the basics for inverses of functions. Make sure that you go back and get all of these notes. Besides that, good luck with the homework. Make sure that you guys practice this.